Hi all, let's go ahead and get started with the graphing functions lesson. This is lesson 2.2. So I know it's not labeled on there, but let's go ahead and write that. So 2.2 graphing functions. 2.1 was evaluating functions. So we're going to take what we did with evaluating and now we're going to use that information and go ahead and graph them. So this very first one here they've given us a table and they've given us the coordinate plane. So we're going to take these values, -2 and 4, to plot them. That means from the origin, we're going to go left 2 and then go up 4. So let's go ahead and look at that. So from the origin, I go left 1, left 2, and then up 4, 1, 2, 3, 4, and that's where we're going to put our point. The next one, it has -1, 3, so go left 1 and up 3. So that's where we'll put that point. Then our next point is going to go not left or right, but it's going to go up 2. So we'll put our point right here. The next one that we have is going to go right 1 and up 1. And then the very last one we have is right 3, down 1. Now looking at those points, I can see that they make a straight line. So I'm going to go ahead and graph that. When we graph that straight line, go all the way through the coordinate plane. Do not stop before you are outside of the boxes. Now, they didn't tell us this stop, so on the left side it is increasing forever and ever. On the right side it is decreasing forever and ever. Now this graph here is called a linear function, so it's a linear graph. The shape that it makes is a straight line. And the equation for this one is f of x is equal to ax plus b. Now, what I want you to really pay attention to on this one is whenever we see an x, the variable x by itself, this one here is where x to a power of 1, this one here is going to create a linear graph. Okay, so on this one, there's an x, and it's x to the first power. So that will always make a straight line graph. All right, let's go on to our next example. Our next example is example 1. Now on this one here, go ahead, use your calculator to help you write the equation and to evaluate it. Remember, when you plug it into the calculator, this is the part that you are inputting. Then inside the parentheses, we are inputting whatever x value they give us in the domain. So here I would put -3. -3 squared is 9. 9 minus 3 gives me 6. Then I'd substitute in -2. -2 squared is 4. 4 minus 3 is 1. Then I substitute in 0. 0 squared minus 3 is -3. Substituting in 2 squared is 4. 4 minus 3 is 1. And then 3 squared is 9. 9 minus 3 gives me 6. Now, when we plot these again, remember our x value goes left and right. The y value, or f of x, that one goes from bottom to top. So if I have -3, 6, I'm going to count left 3 and then up 6. So left 3, up 6 is the first point. -2, so that's left 2, up 1, gives us the second point. And then we have 0, -3. Then I have 2, 1, and 3, 6. Now, in class, I asked you guys to go ahead and make sure that you plot these. Try it with the ruler. See if it gives you a straight line. And when we tried that with the ruler, we could get the line to touch 2 points, but we could not get it to touch 3 points. So in that case, this is not a V shape, as we first thought it was when we glanced at it. So this one, being a quadratic, is going to have a rounded bottom. So this one here is going to look more the shape of a U. Okay. So again, make sure it doesn't have a pointy bottom. We do not want that. That's a different kind of graph. This one here is called a quadratic. A quadratic graph is U-shaped, and that shape has a name called a parabola. And the equation for this one is f of x equals ax squared plus bx plus c. All right, now on this one here, I want to talk about what is it that we're looking for. On the last one, I went ahead and put x in a thinking cloud. On this one, I'm going to put x squared in a thinking cloud. Whenever we see that an equation has an x squared, then we know it's going to be a U-shape. It's going to be a parabola. It'll be quadratic. So this one here has x squared. Someone will say, yeah, but it also has an x. It does. But if it has x squared, that x squared overrides the description. So it will not be linear. It will be quadratic because x squared has the highest exponent. That's the one that we look at, the one with the highest exponent. All right, check your understanding. That's going to be independent practice. That one's for you. I'm going to go ahead and go on to example 2. Now, on example 2, again, go ahead. We would use the calculator. I've already done these ahead of time to save time on the video. So if I was to substitute in -2 into the function, and there's our absolute value bars, so please remember where those are in the calculator. So I have -2 right in there. So I have 1 minus -2 is the same as 1 plus 2. That's 3, and the absolute value of 3 is 3. Substitute -1 into that little set of parentheses there. 1 minus -1, or 1 plus 1, is 2. The absolute value of 2 is 2. Now, if I put a 0 right in here, 1 minus 0 is 1. The absolute value of 1 is 1. Now, if I plug 1 in here, 1 minus 1 is 0. The absolute value of 0 is 0. And replacing that with a 2, 1 minus 2 is -1. The absolute value of -1 is 1. Now let's go ahead and plot those points. So left 2, up 3, left 1, up 2, left 0, up 1, and then I have 1, 0, and then I have 2, +1. Now at first I was thinking, man, this could be linear, but then as soon as I see that it starts going back up, I know that it's not linear. Now this one does have more of a V shape. This one here, I can go ahead and connect those points with a straight line. Then a graph turns around and goes the opposite direction, also creating a straight line. So this is called an absolute value function. Now, absolute value function will look like a V-shaped. The equation for absolute value is f of x is equal to a absolute value bar, b times x minus h, close the absolute value bar, plus k. Now, if you notice on this one, the x is actually inside of the absolute value bars when we're looking at the equation, right? So because the x is inside the absolute value bars, that's when we know it's going to be a V-shaped graph. So here, to give myself a hint, if I have x inside the absolute value bars, I can expect that it's going to make a V shape. Okay? All right, then there's check your understanding 2 is your homework, as well as example 3. There's 2 problems there. So 4 examples for you guys to do before class tomorrow. Again, let me go over, talk about something really quickly. If you only see an x, or an x to the power of 1, then it's going to be linear. Okay, so x to the power of 1 will be linear. If you see x squared in an equation as the highest exponent, or the highest variable term, then this one will make a parabola. If you see x inside the absolute value bars, then this one will make a V shape. Okay? So 4 problems to practice this evening. Message me if you have any questions.